All right, good morning, everyone, and thank you for joining us. We're going to go ahead and get started. So my name is Hayley McGill, and I'm on the marketing team here at IIA. And I just wanted to welcome you all to today's webinar, the DataOps Transformation, 7 Steps to Prevent the Great War of Data Scientists. So we here at the International Institute for Analytics, otherwise known as IIA, host a webinar series that highlights important concepts, techniques, and strategies in the world of data and business analytics. So our clients rely on us here at IIA to provide unbiased insights and a range of perspectives from our network of independent analytics experts and practitioners. So before I introduce today's speakers, I want to take a second just to cover a few housekeeping items. So we will be accepting questions throughout the presentation. If you just wanted to pop them in the chat window, we will get to them at the end. And if you do have to step away at any point, we will actually send out a recording of the webinar, which will be in your inbox tomorrow. So with that being said, I am delighted to welcome today's presenters, Christopher Berg, CEO of Data Kitchen, and IIA's CAO, Bill Franks. So a little background on Christopher. He is the CEO and head chef at Data Kitchen and a recognized expert on DataOps. So he's got more than 25 years of experience in research, software engineering, data analytics, and executive management. And at various points in his career, he's been a COO, CTO, VP, and a director of engineering. So Chris is also the co-author of the DataOps Cookbook, as well as the DataOps Manifesto, and he is a very well-known speaker on DataOps and presents at a lot of industry conferences. You will also be hearing from Bill Franks, the Chief Analytics Officer here at IAA. So Bill provides perspective on trends in the analytics and big data space, and he helps IAA clients understand how we can support their efforts and improve analytics performance. So his focus is on translating complex analytics into terms that business users can understand and working with organizations to implement their analytics effectively. So Bill's the author of both Taming the Big Data Tidal Wave as well as the Analytics Revolution, and his work has spanned many industries for companies ranging from Fortune 100 companies to small nonprofits. So with that being said, I will now hand you over to Bill.
Yeah, thanks, Haley, and welcome everyone. We appreciate everybody joining today. We know that there's a lot of things going on at everyone's organizations today with the crisis, so thanks for taking an hour out of your day to hopefully have a really enlightening conversation. So the topic today is one that I think is really critical for our member base out there to understand, which is the world of what had been for a period of time now called DevOps in the traditional IT and software development space, starting to become adopted and applied within the analytics and data science space under various names, from DataOps to MLOps, et cetera. And as Chris takes you through this today, he'll fill you in on what all that means. But this is really a set of important concepts that is going to help you improve the impact that the analytic processes you are building can have at your organizations. And so, you know, we're really thankful to have Chris here, and I think what he's going to walk you through will give you some great tangible steps to go back and pursue. So with that, Chris, I'll turn it on over to you.
Great, and thank you, everybody. Thanks for the opportunity to hear me today. So we're going to talk about this thing called DataOps, and we're first going to kind of talk about why DataOps is important. And then second, we're going to give 7 steps, and actually 7 steps plus 3 bonus steps to learn about DataOps, and then some next steps with DataOps. So the first thing is that I've been, as a software engineer and manager for 15 years, and then 15 years running data science, data engineering, and biz teams. And I think through it all, and varying of the technology, a lot of the first idea is that, data analytics is cool. The AI, machine learning, you can't pass through an airport and not hear it. But in my experience, and I think this is backed up by research, a lot of the projects are not succeeding. Models are not getting to production. The number of customers, or with data and analytics investment up, the number of customers calling themselves being data-driven is down. 60, 80, some high number of data and analytics projects fail. And so we've got this sort of dirty secret that something's wrong here. We've got a lot of data, we've got a lot of tools, we've got a lot of interesting roles, but things are not working. And so, why is that? And, I grew up in Wisconsin, and Wisconsin went through this industry decline. And my dad, who was in the union, drove a Toyota Corolla back in like 1980. And, he took a lot of gruff from his union buddies for driving this car, but the turned out the car, he bought it for a good reason. The car was cheaper and better than the American counterparts at the time. And so some way I view the data and analytics industry like the US auto industry in the 70s. We're taking forever to get new models out, to deploy things to production. We just have a lot of errors. Our artifacts that we produce, you could say that they're not cars, but reports, dashboards. And as a result, there's a lot of lack of trust. And as a result, I think there's a lot of team morale issues. And another perspective is that and Gartner just came out with a report that sort of validates this view, is that your teams themselves, if you look at the percentage of time that they work each week, they're not spending enough time on new things. They're spending a lot of time on sort of errors, operational tasks, and there's just a lot of complexities in big organizations. You've got complex organizations and roles, complex tool chains, complex data, and complex collaboration across all these different people. And as a result, in my experience, maybe this is a bit too emotional, but I think data teams are suffering. And I think to be in data and analytics, whether you're a chief data officer, or analytic officer, or anybody in the science, engineering, biz, governance business, you're caught between these three forces. The first is that you have these unaware data providers. People will give you sort of crappy data and not know it. And then you've got really demanding data consumers who say, I can get a box shipped from around the world on Amazon. Why can't I have something? Why can't I have some new insight tomorrow? And then the people who are operating it are sort of very critical when things go wrong. And so you're caught between this sort of trio of pain. And in a lot of ways, it makes for kind of a beaten down, distraught, sort of disempowered environment for your teams to work in. And as a result, teams cannot really kind of create and innovate, or they bounce back between these poles of being both fearful, where they don't want to change anything unless it's written down, or heroism, where they try to do everything themselves. And these polar opposites you don't want to have. You want to have sort of a little fear sometimes, but not fear all the time. You want to have a little heroism, but not heroism all the time. And so the concept of data ops is really about reclaiming that initiative for the team. And if you look at it, think of it like this. It's a set of technical practices, first more, and cultural norms and architecture and patterns that enable kind of four ideas. The first is cycle time. How fast can you get something from the idea in the head of one of your teams into production and then iterate and improve it? And the second is, can you do that without having errors? And I'm going to use the term error in a very specific way here. And what I mean by it is a problem in the data and the artifacts. So that problem could be from data quality, the poor data quality. It could be from having perfect data quality and processing. You could be late. And so cycle time, error rates, and then collaboration across all these tools and pipelines all the way distributed across an organization. And then finally, a clear measurement and monitoring. And so you notice there's nothing in here that talks about do a specific data science model, or here's the ETL you should use. Nothing that says about big data or small data, fast data, slow data, unstructured data, structured data. All that stuff is what data ops acts upon. And so it really is a set of technical practices and cultural norms. And it takes its heritage from agile software development, software's DevOps, and really lean manufacturing. And if you look at it, it's starting to get more and more buy-in. So Gartner put it on its hype cycle in 2018. If you do a 12-week moving average, the search volume in Google Trends has gone up 500%. And there's a lot of increased analyst coverage. If you just sort of Google data ops or Google data ops on Google News, every week there's more and more being published about it. And so that's exciting, because we've been trying to publicize this idea about data ops for 6 years, and it's good to see more people talking about it. And so one of the things that as a kind of a front piece to this is what's data ops versus DevOps, and they're both similar terms. They sound alike, but they're different. And there's actually a whole bunch of terms that are used around ops nowadays. And so there's like a whole bunch of opses, right? There's data ops and ML ops and DevSecOps. and GitOps, AI ops. Like what do all these things mean? And sometimes you're tempted just to go, oh, it's marketing fluff. And yeah, it is sort of marketing fluff. But on the other hand, let's, partly the engineer in me wants to define these terms. And so if you look at the top level of this chart, I think in general, you've got different teams working on a technically complicated thing. And so if you think about how to manage a team where you've got a team of people working on this shared thing, and that shared thing could be an assembly line, it could be software that you're developing or data and analytics that you're developing. And I think the same general methods of thinking about how to manage a team, the managerial concepts of a learning organization, focusing on errors and cycle time and collaboration apply. And then if you look at the next column below, how you actually run your teams, in software and to a certain extent in data and analytics, there's Agile and Kanban and Scrum. And then in manufacturing, there's total quality management, Six Sigma. And then if you look at these words and kind of go down to the bottom of the chart, if you think about the IT and software teams, well, that's DevOps. That's the technical environment that enables you to do Agile and Kanban and Scrum. And there's variations of it called DevSecOps. There's AI Ops, which is the application of sort of data science models to logs. There's GitOps. And these ideas are really focused on IT and software teams. And DataOps is going to the next sort of column. It's really focused on data science and engineering and analytics teams. And it's trying to say, okay, if you really are going to be agile and do iterative development and follow whatever methodology you want, Scrum, Kanban, what's the technical environment that you're going to use? And that's what we call data ops. And there's a variation of data ops called model ops and ML ops. I've actually heard people using data governance ops now. I talked to a company yesterday who's doing data SecOps. So there's, in general, there's these opsy ideas. And I hope that clears up the differences between these terms.
Yeah. Hey, Chris, a quick clarification, if you could, if you just go back
Sure.
one. So to an extent that a company has already adopted in general, say an agile approach, both within IT and ideally within the analytics data science organization, it would appear that they might be well positioned to go after this. Are those kind of a hierarchical requirement? In other words, in order to succeed with data ops, is it a requirement that you have those upper things, or those upper things help facilitate and make it much smoother?
Yeah, I think some idea of doing an iterative development process. And there's, you go to a library and look and type Agile, and there's Kanban, Scrum. There's just a whole bunch of flavors, and that's necessary, I think, but it's insufficient. So I've met many organizations in data who've gotten their CIO says, be agile, and then they put the posters up in their room and they're doing what's called Scrum Fall or Potemkin Agile, where they're doing dev sprint, QA sprint, QA sprint. And so I think the idea of doing iterative development in short cycles is important, and you should instantiate that in some team process. But you also need to have a technical environment to make it happen. So Agile is necessary but insufficient to actually have short cycle, high quality deployment of data science models and analytics. So
thank you. And one quick thing, hey, Haley, if you could just validate, I know that across our client base and calls we've been having, there have been some issues at times with people's audio video. A question or two have come in. There will be this will be recorded. It will be available on the IIA website later if you've registered for the webinar. So if you do end up having some connectivity issues during the call today, don't worry, you'll have a secondary opportunity. Back to you, Chris. Sorry.
Yeah, and so I'm going to go and talk sort of like a bit about how you do data ops. And so if you look at the themes that we brought through and why data ops, first is that we're struggling to be successful in that, we've had this great boom time in data and analytics with every acronym, AI and ML, and lots of companies getting funded, et cetera. And I think, with sort of the change in the recession, I think we're going to enter a time where we're going to have to do more with less. And it's not going to be about, can I get some budget to hire 10 data scientists to hire some, try something new. We're going to have limited budgets and we're going to have to make do. And I think focusing on operations and focusing on operational excellence is a way to help that. And so I'm going to talk through kind of the characteristics of how you would focus on that idea of doing data ops and how you could sort of do data ops yourself. And so you know, we, uh, we wrote this thing called the DataOps Manifesto 3 or 4 years ago, and it's gotten 7,000 or 8,000 signatures, and we sort of basically stole some ideas from software and data science and DevOps, and then we've written a book. And so they're also, I've got 7 steps. The DataOps Manifesto's got 18. The DataOps Cookbook has got 190 pages. So you can all of them are free. You can look at. But let's talk through what I'm going to do. So the first idea is orchestrating 3 pipelines. And the second part is the importance of really automating and testing and monitoring of what's happening. And then we're going to talk a little bit about why version control is important, why branching and merging, about the use of multiple environments and the complexity, about containerization and parameterization. And then we're going to get into 3 kind of what I call bonus, the sort of architecture patterns, the complexity of collaboration in data and analytics, and finally, just measurement of process. And so let me start out. So the first thing I want to do, and this is a bit of a complicated chart, is think of what's in production as an assembly line. And as data is coming in, it's being stored somewhere, gotten from a server, it's being transformed, put in some kind of ETL tool or pipeline. Perhaps there's a data science model being applied to it, perhaps not. It's being visualized, and finally the resulting sort of catalog is being stored. So imagine you create a new table, it gets in a database, there's a segmentation model, it's visualized, and then the new table is stored in a catalog. And there's just like 50 tools in each one of these things, and people love their tools. There's some people like Informatica, some people like Airflow, some people like Python. I never want to get into a Python versus R discussion. Some people like Tableau, some people like Looker. But that's the important thing from here, is to think of it like a manufacturing line and try to have the products that you put out, the data sets, the reports, the dashboards, have very, very low problems. Because rework and fixing what's already in production takes much, much more time. And this is very similar. Think of it like a Toyota assembly line. And so the second part is think of what you do like a software development team, because you have some pipeline that you're moving something from development into production. And in software, they call it continuous deployment or continuous integration. And you've got this, you've got all these different people on your team sitting at their keyboard. And of course, now they're home, they're not in the office, but they're writing something that is equivalent to code or configuration. And maybe that's R, maybe that's a Tableau workbook. And they've got their diverse tools and diverse teams. And there's a process that you have to move that from a development environment into a production and try to optimize the speed for that. And then the challenge is you've got to do these 2 things. You've got to kind of run a really high quality Toyota assembly line. And then you've got to be able to pick up a piece of that assembly line, change it, and get it back into production quickly. Because the high order bit on DataOps is iterative development. And what that means is that your customers probably don't know what they want. And you should show them before you show them something, get feedback, and then iterate and improve. And also it's a humble perspective. I've been in the analytics industry for a while, and I don't know what customers want. And I am just tired of writing 20-page specs and getting their feedback. And it's better to have them feel it and touch it first and iterate and improve than it is to spend, months working on something. And so you've got to do these 2 things. You've got to run a prototype assembly line and change it. And then the third part is that there's another pipeline involved. There's this. If you look on the left, think of what we call the value pipeline. That's what happens in production. And in the middle, there's deployment. We call that the innovation pipeline. That's how you get things into production. But underneath both, there's the environment that they work in, your development environment, your QA environment. And those are sort of foundational for both. And so if you think about it, you've got 3 things that you need to orchestrate. There are 3 pipelines that have gone on. There's the value pipeline, the innovation pipeline, and the environment pipeline. And so you've got all this sort of orchestration, all these series of steps that you need to automate in order to make easy. And that's one of the big themes here is stuff that you think is not that important actually really is important. And I saw this as a software engineering manager. There was once called a release engineer in the team I ran in 1999, and he was paid less than all the other cool Java developers. You play that forward, and that role is now called a DevOps engineer. And that engineer is actually paid more than all the individual contributor software developers because they are so vital in being able to deploy into production faster, manage the environments is part and parcel of a DevOps engineer job. And so that's these three orchestrations, being able to do data to customer value, deployment to production, and both at the same time, I think are really important. And so how can you do that? How can you actually, it sounds good, I want to run a factory and sounds really cool, and I want to deploy fast, sounds good. And I've got all these tools, and when I actually try to do that, things break. So how do you not break things? Well, I think the first thing is, let's take the problem and look at it in two parts. In production, the value pipeline, or what happens in production, you need to monitor or test what's going on, so that when the last thing you want to do is have your customer discover errors. And then in the innovation pipeline, you've also got to test and automate to make sure that things, that when you do deploy a change, it hasn't broken something in production. So let's look at what happens in production. So if you imagine that data's flowing through, going through all these tools, first thing is your data providers perhaps are going to give you some crappy data. You want to make sure that you find it out as soon as possible. And there's a whole bunch of tests and automations you can arrive. Maybe something happened in your business logic in the middle, or maybe something happened with your output. Are they consistent the last time? At every step of the process, think of it as a decoration or on top of what you're currently doing. Do automated testing and actually save the results, because that's kind of valuable. And tests are not just pass or fail. In an assembly line, there's this thing called an andon cord, where in the Toyota production system, you pull it and you can stop the assembly line when there's no problem. And you absolutely need that, right? If your data provider gives you a whole bunch of erroneous data, don't wait until the end to discover it. But there's other things that are kind of warnings, like with data, maybe something's weird. Maybe you should check it while it's being processed. And then like in the Toyota production system or other lean methods, the idea of statistical process control is important. If one of your providers has given you 1 million rows, 1 million rows, 1 million rows, and then suddenly they've given you 10 rows, maybe you should notice that, right? And that's a trend break. And that could be something that you stop. It could be something that's a warning. You just don't want to have your customers discover it. And there's lots
Hey, Chris, can I ask a question here just to make sure people are grabbing this? If you go, I think this is a really, really important point, which is when you're talking about these things, and this may be obvious to everyone listening, but I think it's worth reinforcing and getting you to reinforce as well. This isn't about the classic, we're testing our new process we've just developed to make sure it works okay. And now that we're confident it works okay, we're going to put it into production. And if there's a problem that arises because something breaks, we'll go back. This is literally ongoing testing that's automated and built on top of that production process, so that it's getting monitored and tested as it's running in production, even when everything appears to go well, because no one's actually called you and said there's a problem yet. You're proactively trying to identify those problems on an ongoing basis. Is that the gist of what you're going after there, right?
Exactly right. Yeah. Hope is your enemy. And a lot of people construct these analytic systems based on hope. I hope our data providers work. I hope the server's still running. I hope the person doesn't discover errors. And, I find that frustrating, because I've lived that life of having people call me up and scream at me when things are late or broken or wrong, the sort of shame and blame attitude that happens. And I find that very discouraging. And I think there is a way. And I think if you follow some of these ideas about, on top of every piece of work that you're doing, do some automated testing. And, there's a whole bunch of different ways that you can test. And, you can get a data profiling tool, and you can profile your raw data, and then you can run those rules every time. So if you profile a file and it says this column's got 3 values in, every time you get an update to that file, check to see if that particular column has one of those 3 values. And the logic isn't really that hard. You could just go and, for instance, I put some SQL here. Select count star from customers is above a threshold. If your company's got 100,000 customers and suddenly your customer table's got 1 million customers in, maybe you should check that, because your business users are going to find that very, very quickly. And so there's lots of ways to write tests and lots of logic to do it. And there's sort of a basic level of tests that people think about. And then there's some more advanced tests. Like I think of one, we call it a location balance test. And a lot of analytic systems, it comes from somewhere, it gets into a resting place, it's put into some kind of refined schema, it's cached somewhere in a reporting system and visualized. And so it's follow the bouncing ball on the data. So imagine you source 1,000,000 rows, it ends up being into a bunch of facts and dimensions, and then it's cached into a reporting server for fast query. How do you know that there's been no losses along the way? How do you know that things are right? Especially when each subcomponents of this assembly line may be owned by different people on your team. And is this something that happens every day? No, but when it happens, it's insanely hard to test and find out. And so test across your tools and make sure that you're not having any lossy transforms. And then the highest thing is, I don't know if you've had this experience, I certainly have, where you get a couple of data sets, have a data engineer and a data science and someone who does viz. We work on it for a couple of weeks. We put it in front of a business user. They look at it and go, thanks for all your hard work, your data's wrong. And like, how did they know that the data's wrong? We had all this calculus in college, this guy didn't. And so it's frustrating when that happens. And I think, there's sort of an 80-20 rule that business people apply. The 20% of your customers, your regions, your products deliver 80% of the value, and your business users understand that. And so what you need to do is compare the current value of what they see with the new value if they have. And we call that a historical balance test. And this chart is a bit of an eye chart, but it actually shows that sometimes small data files can have big effects. So if you look at what's happening in production on the left, there's a set of SKUs, product, and then a product grouping. And each product grouping's got 3 products in, and the total volumes across the product's the same. And so if you group up the products by product group 1 and product group 2, you end up with 225 and 350. So now something's happened, and maybe your logic's the same, but someone gave you this file that has a new product group. Is this the right file? Is this the not right file? And notice the groups have got 4 and 2. So everything's the same. You've just gotten this new small file that's gone in, and suddenly your product group 1 is now 358, and your product group 2 is 229. Your business user is going to go, bang, that's wrong. And is that your fault? Is that the fault of the provider of the product grouping file? Who knows? Who even cares? The question's irrelevant. The only relevant question is you should know this before your business customer does. That's the only thing that matters. It's not about blame. It's about finding where the problem is first. And so what we think about is do on top of production, automatically test. On top of your entire tool chain, send alerts and notifications, keep track of history, and make it easy to create tests. And then we talk through all these different test types. And we've written in our book, there's lots of different ways that people can test. And so like, why? Why should you do this? First of all, having low errors means you have more time for innovation because your team is not running around doing data deep dives. It also means you get more customer data trust because you're never going to be able to test enough. And it's much better to say, look, we found a problem or you found a problem in the data, you're right, we're going to fix it, we're going to put a test in so it doesn't happen any other time. And your customers are happy and your team's happy. And what you end up with less stress and less embarrassment. In fact, we feel so strongly about this that we think 20% of the work that your team should do should be these automated tests and monitors. And may seem an incredibly high amount. From a software engineering standpoint, it's actually low. Most software engineers devote 30, 40, 50%. Sometimes when I worked at Microsoft in the 90s, they had 1 test automator for every software developer. So being able to develop this automated test really helps. And then it also helps in the second part. And this is really what's happening in production. Well, you've got this other part of it. You want to deploy to production, right? And if your production's running fine, you want to pick up a piece of the assembly line and change it. Those tests also play a role because you want a button that says, if I change something, I change my machine learning model, I add a new data set, I want to change it and deploy it back into production. So you want to run tests to deploy it to make sure that those rights. And the characteristics of those tests are a bit different. There's a lot of words that people use, unit tests or functional tests or regression tests, performance tests, smoke tests, end-to-end tests. And those are all great ways to categorize tests. But and they all have sort of different points, and the software engineering has a whole nomenclature around this. But the main idea here is that if you look, there's a duality of the tests. So the tests that happen in the production, in the value pipeline, almost all of them can be reused when you're deploying. And so maybe some of them are not. So think of it this way. In production, in your value pipeline, your code is fixed. The stuff that your SQL, whatever, that's fixed, but your data is being varied. In development, your code is varied, but your data should be fixed. And so both those, that's where you can get this dual purpose. And so it's not only do 20% of the tests so you don't end up having embarrassing errors in production, do 20% of your time for testing so you can prove that when you deploy something, it works. And if you're having technical review boards, if you're having meetings where the best people in the company are sort of sitting there trying to give their blessings on whether this code should work or not because they've got the whole system in their head, that's a problem. That's a bottleneck that you should fix. And because I've been that person, and it just sucks to have being the one person in the organization. It sort of gratifies your ego, but what you want to do is take that knowledge out of their head and instantiate it in the lattice work of tests that you can help for both deployment and regression.
Hey, Chris, can I toss in get your perspective on something tied to this? I can hear the collective groans from many in the audience thinking, oh my gosh, 20% of my time, I barely have time to do what I'm doing. How do I possibly put 20% of my time to this? And my guess is that your response would be, by taking the time to do this 20% upfront, it stabilizes the heck out of your life on the back end, because more things will be caught and dealt with in a faster and more automated fashion, as opposed to you feel like you're not spending much time on this today, but every time somebody suspects they have a problem, you're having to go do a whole lot of ad hoc testing on a one-off basis to try and figure out what's happening, and that in total could add up to actually more than 20% in some cases.
Yeah, exactly. Yeah, and I think there's this sort of hair shirt of data, and like I've got to suffer because data is dirty, and I've got to do all those deep dives and run around when things go wrong, and I live that life, and I don't. I think you can sort of throw off that hair shirt and build a system where the system will tell you if things are wrong before they happen or while they're happening. And so it's worth it to do this automation. And it's a lesson that has been learned by auto manufacturing. It's a lesson that's been learned by software. And it's a lesson that needs to be learned by data science and analytics. And if you're focused on the next feature, you're focused, and especially as a leader of your team, if you're feeling so pressured to get the next feature out, you're setting your team up for failure. And I've got a bunch of quotes at the end that sort of talk about that shift in perspective. The operational side is not for lesser beings. In fact, most high-functioning Silicon Valley organizations, the best engineers in the company, are focused on the operations side, not on just getting out the next code feature for someone. Because if you can build a system that can support fast deployment, low error rates, that system itself will enable the team to be more productive and better. And so it's a very fundamental shift in perspective that we're talking about. And I'm glad you brought that up. So the third point, so we talked about orchestrating those three journeys. We talked about the testing and the duality of testing. And the third point is your work's code, and code in the software engineering sense. Maybe it's Python code, maybe it's some configuration of Talend, or maybe it's an Airflow DAG, maybe it's some R code, maybe it's your Tableau workbook. All that stuff is code, and code should be kept in a versioning system. And Git is a fine one. There's other versions of it, but keep it in one place. And I think that because then you can keep track of it, you know where it is. And in fact, it's the intellectual property of a data-driven organization. If you look at hedge funds, they actually take their code that does the algorithmic trading, and they put it under lock and key and separate it. This is the IP of your data-driven organization. And I'm just amazed at the number of people who don't keep that IP in one place, or it sits on the hard drive of your data scientist and no one knows where it is. And what that enables you to do is, once it's in one place, you can do something called branching and merging. And that means I can have my copy of the code and you can have your copy of the code. And then we can have some way to bring it back together when we've each done work. And that's what this diagram shows. And this is very common in a software engineering manager's office. There's a main line and branches off of it. And so you want to give people their own copy of the code to work with, but then allow them to go back. And it's sort of like track changes in Word, sort of on steroids. And in addition to allowing people to work on their own version of the code. You want them to work in an environment that is like production, but not production. And to do that, you've got to coordinate your tools and hardware. You've got to build a sort of a sandbox environment that allows them to not only have the code that they want, but a whole bunch of stuff. And so if you think about it, I want to work on my own version of the code, but I also want to work in my environment that's like production, that may have test data or de-anonymized test data that's like production. And so you need kind of a controlled environment for your experiments if you're a data scientist. You need a place to develop out of production. And so again, this is having those development environments be as close to production as possible is another source of errors. And again, you may think this is sort of lesser mortals work, but making this easy and fast is an important thing. And if you read books on software development, like you can read some of Gene Kim's books, like the Phoenix Project or the Unicorn Project, it's all about people struggling when they haven't done the work to manage these things in an automated way. And I think the same idea plays here in software. And in data and analytics, environments are actually pretty complicated because you want to have people work on things, but then you want to have your tools and the code that has that tools. But you also want to have the right hardware and software versions, maybe the right network configuration, because sometimes development environments are completely physically separate or logically separated from production environments. You want to have test data. You want to keep track of your test state history. And there's a lot of stuff you have to do to make sure that these environments are right. But this is all work that can be done. This is not rocket scientist work. This is infrastructure as code, scriptable, manageable thing that people can make work. And so we're about 36 minutes. So getting into one last point, or point 6, is that you need to reuse. And so there's a lot of copy and paste engineering in data and analytics. Hey, I got a great SQL file, a great Tableau work. Could you mail it to me? And then it gets mailed, and suddenly you have some business logic that's copied 10 times. So think about how to reuse your code, refactor your code. And then there's been a lot of work in containers like Kubernetes and Docker to contain your environment. And so these ideas of thinking of what you do as a complicated system and being able to refactor, improve, reuse, containerize that, I think we need to start doing more of in the world of data science and analytics. And then finally, the parameterization. If you think of these tool chains and all the work you do think of it as a big function. Data comes in, it's processed, it's modeled, it's visualized. That's a big function. Do I want to run it based on a large data set or a small data set? Do I want to run all of it or part of it? And so if you parameterize your processing, you can even create time machines where I want to run it based on today's data, or I want to run it based on last year's data. And so all this, if you think of your value pipeline as a big function, you get some interesting results. And the 7 steps that I think apply to data science, apply to data engineering, apply to every aspect. And even there's some complexities in data science because it's got sort of 2 things that go on. One is the process of building features and then building the set of parameters for the model. And then it's got a secondary process of running that model either in batch or in real time in production. But each one of these steps apply. And in fact, on the right, there's a great article from Google about the hidden debt in technical and machine learning, where if you look at this diagram, that little black box in the middle, that's the actual algorithm and configuration of the algorithm. The rest of it is all this stuff that goes around it. And that, again, that's a very powerful metaphor, not just for data science, but for everything in data and analytics. And our perspective is that whether you call it ML ops or data ops or whatever ops, we've gone through different, or say DevOps for data science and data engineering, that these focusing on the operational side will give you a lot of value. And in fact, it's really one of the only things you actually can control as a leader. You can't make your data scientist make a great model, but you can build an environment for a data scientist to deploy models quickly to get feedback and then learn. And that's what you can control as a leader. And so the 3 bonus steps, and these are, I think in some ways, a little bit more interesting than the other ones. So architecture, collaboration, and measurement. So the first one is, I've been in the industry for a while, and I've seen so many canonical data architectures, and they've changed over time. They all have source data on the left and customers on the right, and they have some process steps that go through. A data lake now is fashionable. It used to be a data warehouse in Hadoop. There's some streaming ones that are fashionable now, or streaming and batch. There's some data engineering that's applied, some refined data, science, visualization, and governance. Every data architecture I've ever seen is very focused on what happens in production. And that's fine, but again, it's insufficient. When you think about data architecture, you need to think about how you deploy as a first order thing. You need to think about the right to change production. And whether you've got a dev or test or UAT, how many environments, the automated deployment of things from into that production really matters. And orchestrating those and monitoring those matter. And actually creating the environments and managing those matters. These sort of green things here, deployment, monitoring, testing, managing environments, these are really first order important things that you should do. And automate and script and make easy. And they're not just for lesser beings. They're actually really important things that you should have some of your best people work on. And so that's it in terms of architecture. So let's go to the second bonus step is on a very different idea on the fact that this is sort of how people are arranged in organizations. And so if you look at that leftmost column, and D here is a development team and P is a production team. You may have a development team and it could have someone doing BI, some people doing data engineering, some people doing data science, some people doing data governance. That's what these two-letter acronyms. And the group is D and the little gray circles are people. And so this is a centralized development group. And the challenge there is just how do you get people to work together, right? When you've got your data engineer and data scientist and BI working on all things. And there, I think, version control can help. Going to the next one, you've also got to think about how does that development team get their work to the production team? Because your production team has got people, how do you deploy? Because they have a completely different worldview. They want it to run. They want to have low error rates. They want to have procedures where they can figure out if something's wrong. And so how do you deploy from your development team to your production team safely and rapidly and with low errors? And that, you've got another team here. And so it's kind of an intra-team collaboration. But there's also, given the sort of world of self-service tools, and whether you're doing self-service BI, self-service data prep, self-service data science, we end up with this third column here where you have decentralized development, where maybe you have a data enablement team or a data warehouse lake team running at the corporate level, but in the line of business or individual group level, you have these further development teams, and maybe they're using Tableau or Alteryx to do their work. And, they don't work for the same people. You've got maybe a centralized development team for a CIO, but you've got these individual line of business teams. And the value that your customer receives has to work its way through this network. And so how do you balance sort of the centralized control versus self-service freedom? That's a really important topic. And, there's a lot of people have written about it. And you've even got this further complexity, right? Where you can go into Tableau or into Alteryx and hit a button and deploy to production. And so you have a way to do production in a self-service way, but you also have a way to do push to production in a development way. And so how do you manage this whole sort of mesh of development teams and production teams? And so you end up with this sort of kind of cornucopia of collaboration complexity, if you don't mind my alliteration. And I've presented this at a bunch of conferences, and I think most people end up all the way on the right. They've got sort of one of each, they've got centralized and decentralized. And so that just creates a great sort of collaboration challenge in data and analytic organizations. And if we look at that in a simpler way, less abstract way, let's look at it this way. Let's say you've got two teams. You've got a home office team. Here in Boston, they're producing a data warehouse with some batch data science models in SQL Server and Python. And then you've got a bunch of local office teams, and they're using Alteryx and Tableau. Maybe they're in New Jersey or other places around the organization. And the end business customer, in this case, a VP of marketing, sees the sum of the value of both. There's some tables and schemas that are in the database, and then there's some visualizations and data prep that happen on top of it. And they don't know where the value is created. Is it the local office team? Is it the home office team? There's good reasons why you want to have your data analysts embedded with your business user. But there's also good reasons why the logic that they create should be farther down in the chain. And so you end up with this situation where you've got this set of problems. Like if I'm on a home office team, how do I change my schema? Because I don't know how many reports are using it, how many data prep are into it. And so I'm sort of locked. I just have no idea. And if I change the schema or change the meaning, then everything breaks. And that just seems like an kind of insane thing to me. But not a lot of organizations have that. Or if I'm working in a data prep, I add a new data set. How does that get back into the home office data warehouse? And in a lot of cases, people who are using these self-service tools are copy-paste engineering. I got a Tableau workbook. It's great. In that Tableau workbook, I've created a calculated field. I've created an if-then-else statement, in effect. And I've mailed it to someone else. They mailed it to someone else. And soon that if-then-else statement, the same copy of it is in 10 or 15 reports. Now, what happens if that if-then-else statement needs to change? Well, then you've got to find which report it's in. And so you could argue then, well, that if-then-else should be centralized, and perhaps that's the right term. But on the other hand, that the people who are using those self-service tools are discovering the requirements and discovering the if-then-else. So these inconsistencies and challenges, and whether you're let 1,000 flowers bloom, or you want to have the hammer of the centralization, this is the way the world is. And it's just hard. If you've got to have some new data in a schema, then you've got to update a report. And this kind of collaboration just creates a lot of challenges in organizations. And so I think the idea of what we talked about in the first 7 steps, these ideas in DataOps, they apply to central organizations, but they also apply to decentralized organizations. And
hey, Chris.
Yep.
One thing here, because this kind of jumps out at me. Let's just take the bottom one. There's new data. Either new data in the given schema or they update the schema. And so now a change has to be made in a report. If you were following the principles you laid out at the local office team level, presumably there would have been a test that would have been checking for if there was new data and or a new schema that would have alerted that local team that there was a problem as soon as it came in versus after the report breaks when the VP of marketing runs it, or worse, the VP of marketing gets the report and can just tell that the data is wrong. Is that where that's where you'd be heading?
Yeah,
right?
I think that they both have value. So imagine, I've seen centralized IT teams and they've got 1,500 Tableau reports running around the organization, and they can't change anything because they're fearful that the CEO's report's going to break because he checks it every day. And so the way to get around that is to say, well, what happens if you did automated testing of all those reports? And so if you did change the schema, could you in development see that you've broken the CEO's favorite report ahead of time? And then you could correct that problem, either fix the report itself or fix the schema or both, and then deploy those things together back to production. So testing and automated testing is not just for things like ETL or models. It actually is for these data viz and prep tools, because people are, in the software world, there's sort of high code and low code development tools. And we've got a lot of low code development tools in the data and analytics world. Sort of Tableau and Looker and Paxata, Trifacta, they're great tools. But at the end of the day, my perspective is whether you use a nice UI to build code or you actually write the code itself, at the end of the day, it's code and it needs to be tested, it needs to be put in version control, and you need to handle these organizational complexities so you don't run into embarrassing production errors, which frees the organization up and causes you your CEO to send you that email at 9 p.m. on Friday saying you better fix this by Monday morning, which sucks. And I sort of got tired of having that happen to me and having my wife give me dirty looks when I was going off to fix data errors every Saturday morning. So I think there's a better way to live. And the third part of this actually comes from my management experience. And this is the last of the 7+3 steps, is that if you're running a team, you need to get analytic about how your analytic team is working. And so you need to measure your team. And so you need to measure each of your team's productivity. You need to actually measure your error rates, how things are going wrong in production. A lot of people who do data analytics have hundreds of data providers, and they have no idea which one is late, which one's giving them crappy data. You need to measure whether you're meeting your SLAs. How fast are you deploying to production? How many environments are you using? In fact, what is the test coverage across all your tools? And this stuff is actually really important metrics for you to understand. And here's a report that shows on the left-hand side, we call it a tornado report. Because this is a case where there's a company's got like 75 data providers, and we've kind of grouped them up here. But like one case is the data provider gives you an error, right? And that's this, there's severity and then cost, how many hours to fix it. And so by putting this in a report, it gives you leverage on those data providers saying, hey, look, this last week you gave me an error, it cost me 20 hours of work. And its severity was so late that my whole production process. And you need to sort of make this visible so you can, as a leader, get leverage on your data providers that they're, screwing you over. And then the second part is looking at your team as a whole and trying to understand how they're working. And this is a project dashboard. And so if you look at it and there's some things that you want to understand. And first is like, how productive is the team? And productivity is kind of a mushy thing. Like even in software, is it feature points, story points, is it code commits? And there's lots of different ideas, but you should measure how much your team's working and even measure the coverage of how much tests they having. You should measure your SLAs. Are you on time? I think it's really important to measure how many errors you have. And one of the things that started me on the data ops journey was I was in charge of a team that was producing analytics for about thousands of business customers, and we kept having problems. And I kept blaming people, saying, "Oh, it's good. I fired some people." I was looking for the special cause in Deming term, but it was really a process cause. It was really my fault as a manager. I hadn't arranged the process. And so what we did is did some really simple things. We did a quality circle, and every time we had an error, we created a JIRA ticket for it. And then every 3 weeks, we'd sit down and look at all our JIRA tickets and see if we could find patterns. And then we slowly automated ourselves. And I tried to change the team from the shame and blame with errors to a love your errors, they're opportunities for improvement. And I think by taking these things and putting them in reports and making them visible, it can help that cultural change in your team. Instead of trying to hide your errors, you try to say, okay, we screwed up, let's have a postmortem, let's figure out how we can improve. And so that's really it in terms of data, in terms of the 7 steps plus 3 on data ops. And so like, this all sounds good. So what are your next steps? And I think, I guess the first is like, well, why do you want to do this? Like, what's the benefit? So what we've seen with people who've adopted these principles is that they actually do end up spending a lot less time on this error and operational task, and they do get more time for features. And as an engineer, I also want them to do more times for improving their process and reducing their technical debt. And then we also see they can deploy faster and they get less errors and their teams are happier. And so here's that last chart I alluded to and sort of the mind shift that we're looking for. So, Elon Musk and Tesla starts talking about that the true problem in building the sort of Model X and Model Y was the machine that makes the machine. It was about the factory. And he thinks of the factory like a product. Satya Nadella, who's done an amazing job turning Microsoft around, he has a quote: if any engineer has to choose between working on a feature or working on dev productivity, always choose developer productivity. As I said, the salary for a DevOps engineer is roughly 20% more than a traditional software developer. Google has 2,000 engineers to contribute to engineering productivity. So it's a focus issue. If you focus on these things, they happen. And if you think about the machine that makes the machine, you focus on productivity, you focus on data ops, and you can actually get the benefits, and your team can actually produce more faster with higher quality. Your customers will be happier. And I think you can end up doing more with less, which matters in this time. And so as a company, we've written a lot about the concepts of data ops, the manifesto, the free cookbook, even an excerpt from Gene Kim's book, The Unicorn Project, talks about data ops. So all these resources are free for you, and they're all sort of all about these best practices. And so that's it in terms of my presentation for today.
Hey, well, thanks so much. Very informative. Before we turn it back to Haley to round out, but we've got a couple minutes here. There's a few questions that have come in from the audience, and I've chosen a few I think would be great to throw out to you. One of them was from someone who comes from a smaller organization. Their whole team is south of 20 people in the analytics space. So he was wondering, what are your recommendations about how to scale down some of these processes to make them manageable, but also still effective when you don't have the ability to scale the whole organization?
Yeah, and that's a really a good question. Is like, when do you want to start data ops? And so if you look at, I think you should try to find where you can apply some of these principles first. And oftentimes I find organizations have two areas where they want to focus. One is, I just want to reduce my errors in production, and then just start writing some automated tests that run in production. You can do those as part of your ETL job. You can do them before the data arrives. You can write scripts afterwards, but script up the tests and make sure that you're reducing your error rates in production. And that's not a new technology thing. That's just you thinking about it and getting time to do it, and allocate in every sprint or every cycle some time to do that. Or the second area where people focus on is just, it takes them months to deploy, and start looking at, why is it that it takes you months to deploy? What lack of, can you script and automate yourself around it? So I think these principles scale up from one developer all the way to hundreds of developers. It's a matter of where you apply them, and also it's just and I guess I just grew frustrated. I grew frustrated with running a data and analytics teams where the expectation was something was going to go wrong every week. And I've talked to organizations who are very proud that they got major data errors down to 1 a month. And like, I think you should have 0 major data errors, because you should have caught any data error before it got to your customer. And it's not that they go away, it's just that you understand them and catch them and notify them, and it's a handled process. And so I think those are important things to do in varying of size.
All right. And I'll give you one more, and we'll only have about 2 minutes for the answer, but it is an intriguing one about how would DataOps apply in some of these middle grounds that you might call, pseudo production. You're doing a proof of concept or even a pilot where it's not fully rolled out yet, but it's more than development. How would you recommend handling that as it relates to these processes?
Yeah, well, I think they're a matter of degree. And so a lot of times when you're doing the purpose of iterative development is to get feedback quickly. So almost everything is a proof of concept in some ways. The first version of a data set, the first version of a visualization. And what you can do is give things to your customer saying, here's a draft. The data is not particularly right. I only have 1 or 2 tests on it. Can you take a look at it and see if I'm in the right direction? And what that allows you to do is be able to, it's almost like a superpower. Give them something quickly, get their feedback, but change up the quality as an artifact and say, okay, we're going to make some changes. We're going to add some more tests in, and we're going to data opsize it, industrialize it, factoryize it later. And so I think the whole point is to be able to try stuff out. And the things you can vary on this are the amount of testing you have, and even the design. You can try to do some things shortly in design and then improve the design later. And so refactoring, adding tests is part and parcel of being able to handle an iterative development approach.
Well, thank you so much. This was really informative. I think you had some great points in here. I know, Haley, you'd like to wrap things out with a couple of comments, so I'll turn it back to you to finish it off.
Thanks, Bill, and thank you, Chris, for your presentation. It was great. So as I mentioned earlier, we will have the recording out in inboxes tomorrow morning. So if you did miss anything, don't worry, you will have access to the full recording to watch on demand. So you can also check out our webinar library on our website as well, which is iianalytics.com. And keep in touch with our social media channels to see what we've got coming up. So thanks again, everyone, and have a great day.